Eating all the candy on a Halloween night. Okay, so in our second Unit 3 C2 problem for vertical motion, we have a volcano ejecting a lava bomb straight upward with an initial speed of 23 meters per second. And if we take upward to be positive, so we're going to assume classically up is positive and down is negative, we're looking for the velocity of the lava bomb after 2 seconds and then 3 seconds. So let's draw ourselves a little picture, make Grandpappy Bots proud. So here's a volcano, poorly drawn by yours truly. Here's a lava bomb. And if we just doodle some stuff in here, what do we know? We know initially it has an initial velocity of a positive 23 meters per second. And we know a time for part A is 2 seconds, and part B it'll be 3 seconds. We are looking for the final velocity here. So we're looking for what is VF. And this is a bit of an issue because I only have two things at the moment. I have time and an initial velocity. So what do I implicitly know due to the fact that we're here on Earth? And what can I think of as a physicist in order to give us a little bit more information? Well, if this lava bomb here, if it's going up, we know it's going to be slowing down. It's going to get to some max height, and then it's going to fall back down. The thing that's causing it to slow and then fall back down, that's gravity. So we actually know that the acceleration due to gravity is that 9.8 meters per second squared, and we know that it's in the downward direction, or inward towards the center of the Earth, and that means that this acceleration is negative. So now I have three things. I've got VI, I've got T, I've got A. I'm looking for VF. I can pick an equation, number 3, 4, 5, or 6 from our best friend sheet, our motion equations to figure this out. The one I want to pick is equation number 3. If I do this, I say that VF, the final velocity, equals the initial velocity plus an acceleration multiplied by time. And in this case, this equation is nicely set up for us, no real algebra to do. Our final velocity is just the initial, 23 meters per second, plus negative 9.8 meters per second squared, that's our gravity, multiplied by our time of 2 seconds. We put all that together, and if we start mathing this out, we're going to get 23 meters per second plus negative 19.6 meters per second, and this is going to give us that our final velocity here is, what is that, 3.4 meters per second in a positive direction. So after 2 seconds, the lava bomb is still going up. For part B, it's the same thing, but we're just changing this 2 here to a 3. So now what we'll have instead is just the final velocity will equal 23 meters per second plus negative, and then whatever 9.8 times 3 is. So 9.8 times 3, so negative 29.4. Which gives us a final velocity here of negative 6.4 meters per second. And this negative does matter here. That negative, because the velocity is a vector, that negative represents that the lava bomb is coming back down at this point in time. It's gone up, it's hit that max point where the velocity is 0, and we're now coming back somewhere, okay? We're not all the way at the bottom yet. To be all the way at the bottom, our velocity would have to be negative 23. It'd have to be the negative of what we started with because we're back to that same initial position. But in this case, we do know it's coming down at that speed. Okay, so that's why we take a problem like this. It's just another free fall problem, vertical motion. Look what you have, the 3 things you've got. What equation are you using to find your unknown? And then it's just a matter of solving out the math. So with this problem is finished. Adios.